A couple of things that is going to be different from the past is that in the past, we would actually have you guys purchase a lab notebook. And then when you're doing the experiment, you would write everything in that lab notebook as you perform the experiment. Then we switch over to the electronic notebook in which you were typing everything that you did during the experiment. And Lab Archives has a way in which you can actually dictate the results or what you observe. So it's kind of nice that you can do that. If you have like a phone, you can smartphone, you can connect it to Lab Archive, and then you can dictate your observations, etc. You still have to write the pre-lab and then of course the post-lab, but that was Lab Archives. Because we are going into Canvas and because all the experiments are videotaped for you guys, then the logistics by which you guys carry out the experiments and document the experiments are going to vary slightly. And let me try and make sure that it's clear what is required when you guys do this experiment and turn it in, okay? Even though you guys don't have the experience, you guys will be able to observe what's supposed to happen, and you are still responsible for documenting what you see in those videos. That's important. I'll show you how students in the past have been able to document that in their lab book and then put it into their reports, okay? But since we are not in lab, and since we are not using Lab Archive, get yourself a composition book like that, okay? It's about $1 or $2 from Walmart or Target, okay? Even big lots have them, and they're not that expensive, but it's a permanently has permanent pages, so you're not ripping them out. And then what you want to do is you want to document your work in here as you are doing the experiment. I'm not collecting these, okay? This is for your benefit. That way everything is sort of contained in one place and you don't have loose pieces of paper flying everywhere, but it's documented in one place, because in the end, when you guys are taking a quiz, like, or the midterm and the final, you can use your documented work. If everything's compiled and found in a location where, and it's well organized, then you will be that better off in answering some of these questions. Because what I will ask you is, how do you do this calculation? Calculate the concentration of this based on these observations or based on this data. And it's easily forgotten if you don't have it documented somewhere when you're doing the experiment. So get yourself one of these. Try not to use loose leaf of paper. That's just bad habit, but a composition notebook. And then start on like page 4 or 5 and leave the first few pages for table of contents and information that you will use often, like the molar mass of certain chemicals or the density of certain chemicals, because you might be using it over and over again. Anyway, I'm not collecting these. This is for your benefit, but you want to make sure that you practice good science when you are in a science course. And good science means you document your work in a permanently bound notebook, okay? And this is the notebook that I would suggest. So the notebook is probably the one most important piece of item that you have going into the laboratory. Of course, you need the chemicals and the equipment, but when you're carrying out the experiment, the notebook is so important. And if you work for a company, or maybe you're a pharmacist or a doctor, you want to keep documentations of what's going on. That way, if you discover something, you work for a company, for example, they can actually subpoena your notebook in order to get a patent, or if someone questions the validity of your discovery, the notebook is where they're going to look in order to verify that. So in terms of our class, like I said, it's not being collected, but you do transfer the information from that notebook, that composition notebook, to your lab write-up. So it's good to have. And try and be legible, because if you are not legible, then when you try and interpret what you wrote down or the observations that you took and you can't make it out, then it's not going to do you any good. Okay, so that's very important. Plus, it's just good training as you move on to organic chemistry, because in organic chemistry, we should be done with this COVID by fall. Hopefully, we will have face-to-face meeting, and you guys are going to be responsible for writing up your lab reports. And I know that for most of you, you've had 3 semesters now in which everything was virtual. Maybe the first part of, or a quarter part of Chem 152 was not, but for the most part, you don't have the training of going into the lab and actually handling these chemicals. So you're sort of behind in that sense, but it's, as long as you follow it in terms of these videos and you practice in terms of writing up these reports, then you shouldn't miss a step. Okay, you shouldn't miss a step. So, right, this page right here just tells you the importance of keeping a very good lab notebook. Okay, it's very important, especially for those of you future doctors or scientists. Keeping a laboratory notebook is so essential. Okay. Of course, we have Leonardo da Vinci to look back on. And if we can keep a lab notebook like he did, where he was both very observant of what happens. And then the neat thing about his notebooks is that he had a lot of illustrations. Because what's the saying? A picture represents 1,000 words or something like that. And so what I will try to do in my course is I will ask you to diagram a pictorial flowchart of the procedure. And that's to give you some training on sketching what's going on in the experiment. Okay, so it's taken from Leonardo da Vinci and the way he sort of illustrate a lot of his observations. And I think it's a good skill to have as you move on. And you can just see the beautiful sketches he had. And yeah, I'm not a great artist, and maybe some of you are not, but make an attempt so that you can hone in that skill. Because like I said, it is quite important in terms of when you document your work. Okay, so these are the components of a lab notebook, and I will go over each one of these in detail as we progress through this discussion. Pay attention to the format, okay? And the format will always be given to you in the grading rubrics that is found in each information page in the modules, okay? The format consists of the pre-lab, and the pre-lab is all this based on that order. You write the objective, and the objective is basically describing what the experiment is about, the goal, the system to be studied, and maybe the techniques that's going to be carried out. It should be very short, maybe about 2-3 sentences at the most, okay? It tells the reader right away what this experiment is about, and an idea of what system is going to be studied and how it's going to be studied. So these are the components of the pre-lab: the objective, the background information, safety, and I forgot, in the background information, you should also have the procedure and a sample data set, the safety, and then any pre-lab questions. That's all due before you even start the experiment. So if you were meeting on campus, before you walk into class, you would have submit this through lab archives, or complete it in your lab notebook and turn it in to the front desk. Of course, that's not the situation today, but just to remind you, that's probably how you would do it in the OChem course if you move on to that level next semester. Then when you are in lab, you guys are going to be carrying out the experiment, And the important part of carrying out the experiment is your observations and any data that you collect. Okay, so you're actually documenting these things and writing the data in real time as you do it. You don't like write it on a piece of scratch paper and then think that, okay, I want to be really, really neat in my lab notebook, and so I'll put it here in the scratch piece of paper and then I'll re-enter it later on. No, don't do that. Just put it in your notebook, and it's okay if you're a little bit messy. It just needs to be legible, but you want to document it as you are collecting it, as you are observing that particular experiment. Of course, all the experiments are videotaped, but try and since it's videotape, you could always rewind it, but try and simulate what it would be like if you were doing the experiment, as you make that observation, as you look at the data that's being generated based on the technique that you're carrying out. That's important. And then this section is generally due after you've completed the experiment on the same date. So if it's a 2-day experiment, you don't really turn in anything on that first day, but second day at the end of the experiment, you would have completed that experiment. You would have already compiled your data and observation, and then you would have turned that in. If we were face-to-face and you're writing in a lab notebook, then you would just rip off those pages and turn it in. If we were in lab archives, you would finish typing in your data and your observations and then submit that. That's not the case, of course, because like I said, everything's videotape and you guys are going to be given more time to make sure you complete this. So keep that in mind. Then you guys will be given a week and a half to make sense of the data that you collect and to do the calculations. So if you finish on a Wednesday, then that whole following week, nothing's due until the Monday that you return, since our class meets Monday and Wednesday. So you're given a week and a half in order to write up, make sense of the data, compile the do the calculations and compile the results, write a summary of the results, give a discussion of your interpretation of the results, what it means, what's going on, and then answer the post-lab questions. That's the post-lab write-up. This is the pre-lab write-up. The pre-lab you do before you start the experiment, the data and observations you are completing as you are doing the experiment, due right when you are done or the same day that it's done. And then the post-lab, it's due a week and a half later. Okay, so I'm going to go into the details of each one of these sections, but that's the 3 sections that you guys will be submitting. And in Canvas, those are the 3 sections that each experiment is broken into: the introduction, the pre-lab, the data and observations, and the post-lab. You always see those 3 sections in Canvas. Of course, some experiments will have a quiz component, and the quiz components are due the same time the post-lab write-up is due. Okay, you can complete it anytime before then, but you need to submit it before at the same time the post-lab write-up is complete. So general guidelines are the following. Like I said, it's kind of confusing because there's different formats, and the different formats as if you had a composition book or a regular lab book, or versus lab archives, and now we're doing Canvas. But you should be able to distinguish one statement for the different scenarios that we have. Like for this one, save at least 4 pages for the table of content for typical lab notebook. Well, you guys are not really, unless you have the composition books, do that. Okay, if you're keeping a composition book. If we were in lab archives, you don't have to worry about that, because let me show you lab archives real quick so that you guys can see how it was done. And that's basically the template that we are using for Canvas. So let me switch screen here. You would log in here, and what we would do for you is we would give you all this information right here. The information of what you would need to complete. These folders are where the experiments would be written up. And then what you would be doing is you would be generating the report within each of these folders. Okay, so that's what Lab Archives gave you. And if you take a look at this right here, this is nothing more than the description of the experiment for experiment number 1. And then you would open this page up, the introduction, and then you would basically start writing your introduction of this experiment here. You would open this page up. Let's abandon this. And you can see there's really nothing in those pages, except that's the shell. That's the container where you would write up the data and observation. That's basically what Lab Archives gave you. But the information of the experiments all in the beginning here, just like we see in Canvas. In Canvas, let's take a look at Canvas real quick. Okay, let me go to the module section here. If you take a look at an experiment, like the first experiment, kinetics, this is the information page. It gives you a description of the experiment taken from your lab notebook. Another neat part about this is you can get the grading rubrics for the experiments right here on this page as well. And so you can see the criteria of how you are graded. You want to use that as a guide when you do a write-up. So that's that first part of experiment number 1, just giving you general information. And then there's going to be a place where you guys are going to write the introduction section. So let me find that. It's got to be in the module right here in the module. You can find that over here, introduction. Okay. Now what I've done is I put in here what the introduction section is. But as a student, what you guys will see is a box over here on the right side. Let me see if I have that. Let me see if I can put that setting on student view. Okay, let me go to active experiment number 1, introduction. So right here, submit assignment. So you would click right here, and then down here in this box, you would start writing up the introduction. Okay, and then when you are done writing up the introduction and answering or putting the information in the introduction that I'm going to be talking to you about today, then you submit it. Okay, and you need to submit this before the due date. And the due date on this is going to be, for this experiment, the due date's March 1st. So you can see that our first experiment is not really worked on until towards the end of February, okay? And that's because we want to make sure that you're well caught up in the lecture on kinetics before you do this experiment. And March 1st is when it's due, but you can turn it in as late as March 3rd. Okay, let me go back and show you the data and observation. Again, you got to go to the module page. And in the data and observations, it's a separate section now. It's a separate section right here, data and observation. And you click on this, you can watch the video. In fact, you want to take screenshots of the video in a different important part. And this is all information that you would need in order to make sense of the experiment. And then when you're ready to write it up, click on submit assignment here. Okay, and then you can use this box. Okay, if you don't want to submit it because it's taking you a few days, then just kind of leave it as is. Nothing's really going to happen, but don't submit it until you are ready to submit. Either that or write it up in a Microsoft Word document or some document and then just copy and paste it in here. Okay, don't copy the file, but copy the content of the document in here. It's got to be live. It can't be just like a page and then I have to open up the page. You actually have to write the content in this box. Okay, so hopefully that's more clear as we step through and I talk to you guys and show you examples of how to keep a lab note. So again, these are guidelines if you were keeping a lab notebook. Okay, this is a good composition book. Each section, remember we have 3 sections: intro, the data and observation, and the post lab, should have a heading, and the heading should have your name, the title, and the date, title, and experiment number, and the date that page was completed. Okay, the entry of that particular page. So this is how it would have been done if you were keeping a lab notebook. But notice this person has the date, the experiment number, the title, and then of course their name is in here somewhere, right there. And you guys don't have to worry about witnesses because you guys are not doing the experiment with a partner. In fact, in Chem 201, you don't generally do it with a partner, you do it alone. So that's what's in the heading of each section. Because we don't have pages in an electronic notebook or Canvas, then just make sure it's on the top of each section of your report. Okay, so this is what it would look like if you were keeping a lab notebook. In terms of the objective, this person wrote the objective and they tell you in not so many words exactly what that experiment's about. The purpose of this experiment is to understand and design electrolytic cell. Okay, so you're going to kind of break down electrolytic cell, understand how it's behaving, and then they're designing it as well. Several electrolytic cells will be observed to determine what reaction is occurring and the chemical process that is involved. So this is sort of to the point, and it tells me right away that this experiment is under electrochemistry. Then they give background information. So those are the things that you guys need to break, to make sure you break it down to. In fact, if you, let me go back to Canvas here. Okay, go back to Canvas. And this is the order that I would like you guys to write up your report. Let me blow this up. Okay, so if you see right here, you can see that it's the introduction and procedure. The introduction consists of the objective and of the experiment, the background information, the procedure flow chart, the safety, and then the pre-lab question comes at the end, not at the beginning, but at the end of this section. Then you have your data and observation as part 2. You need to write your observations and then the data and any graph that's generated. So that's the order that I would prefer that you do your write-up on. Don't put the pre-lab before the objective, okay? Don't write your discussion before you do your data and observations. Don't write your discussion before you calculate the results, in other words. So this is the order that I'm looking for when you write up your report. Okay, use the grading rubric as a guide for that. Here's more details of the background. This person, the background should contain sufficient information so that any reader who is looking at this report will know exactly what is involved. They know exactly what reactions are being studied. They know what techniques are being carried out, and they know the mathematical relationship that they're going to be using to establish a correlation. And that's what you see in this example right here. This person, I think this particular experiment is about, let me just see. This experiment is actually experiment number 3 for this semester. They're determining KF. So they write the reaction that's being studied. They show that the concentration of these chemicals are going to be done by Beer's law. And so you see Beer's law right here. And then they show how Beer's law and that information is used to calculate the concentration of each one of these components in the mass action expression, and basically give you an idea of the math that is involved. So this is a pretty detailed uh, introduction section. In other words, by the time I'm done reading the introduction section, I know exactly what reactions are taking place or going to be studied, what mathematical relationships are going to be used, and the calculations that are going to be involved, and what the significance of that result is going to be about. Okay, so that's the background information. Here are more details: reaction being studied, the essential math, okay, the possible correlation, the theory supporting the data, or the theory that's going to be used to be validated, the summary of the calculations that are going to be taking place, and then the mathematical relationship that's going to be used in this experiment. The procedure, I'm not really, so that's the next part in the intro. This is still in the introduction section. After you get the background information, then you're going to talk about the steps by which the experiment is carried out. I don't really want a verbatim list of what is in the lab manual. Okay, I prefer not to do that. In fact, what I really want you guys to do is give me a pictorial flowchart. This is where you start honing your artistic skill in sketching these things. So rather than just give me words as to what the steps are, I want you to show me snippets of what the steps are in terms of a pictorial flowchart. And I'll give you an example here. Okay, this right here tells me, I can see from this illustration that I have to prepare a sodium hydroxide solution in a graduated cylinder. Okay, and it tells me that I also need another solution of crystal violet and what that concentration is. And then I need to set up my computer, because what I'm going to do is be recording the absorbance of that. What I will do is I will set up my cuvette. I will mix these two chemicals, and then I would put it in the cell where the absorbance are going to be read. So you can see right away from this example that there are no words in terms of the steps that are being carried out. Instead, there are small description, okay, and then illustrations of what's going on in terms of the steps. And with one glance of these things right here, I know exactly what's taking place. The reason why I prefer this method, and it's unorthodox, is because I really want you guys to walk in your mind, in your mind's eye, actually run the experiment before you actually do the experiment. And the best way to visualize the steps of the experiment before you start it is to draw yourself a pictorial flowchart. Okay, take the words that is written in the lab manual and then write it up as a pictorial flowchart. That way it's clear in your mind what the steps are. So that's why I prefer this method versus a laundry list of what steps are to be done. In fact, this is perfectly fine without all the words that are added to it. Okay, so keep that in mind. This experiment has more parts, of course, because it has to be repeated 3 times at 3 different temperatures. And so this is what's involved at the end. What this person is doing is they're graphing the results, and they're able to compile that result and make sense of it. And then that's the data. After you show a pictorial flowchart, you need to give a sample data table or sample data heading of what information is to be collected. And again, it's a way to ensure to me that you are prepared. If you don't know what data to collect, then you're going to get lost. But if you already visualize that, okay, these are the key information that I need for this experiment, and this is the type of data table that I would be needing, then you're that much better prepared for the experiment. Okay. Um, then after that, remember that the background information contains all the information, theory, mathematical relationship, equations to be studied, the procedure, the table of the data table, sample data table that's to be generated. After that, then we have the safety. Okay, safety information. You need to write about the chemicals that are being used. You should be able to see from the write-up what chemicals are going to be introduced in this experiment. There is a website where you can find the safety data sheet, SDS. And the safety data sheet gives you information about the chemical that you might be exposed to, its handling, whether or not it's toxic, whether or not it's flammable, etc. That's what the SDS is. But I don't want you to just give me a document and put it in Canvas. What I want you to do is take a screenshot of that document and then paste it within your Canvas so that I don't have to open up a new document. I can just see it in your Canvas write-up. And I'll give you an example of how that's done. And then, of course, you also have to write in words some of the better known safety regulations, and then how to dispose of chemicals in the laboratory, or how we would dispose of chemicals in the laboratory, and any other precaution. Okay, so again, I'll give you examples. Right now, I'm just generalizing what's going on. Here is an example of what this person did in terms of safety. Back then, this is probably about a 12, 15-year-old document. Chemistry has not changed. So what they did 15 years ago is the same thing that you guys will be doing today. Okay, maybe we've optimized the experiment a little bit, but what I learned in graduate school, what I learned as an undergraduate, is the same thing that I'm teaching you guys. Okay, so here this person is writing the safety precaution. It actually should be more detailed. I'd like to see more. Giving information about some of the chemicals that's being used, and then how to contact this, and any type of disposal information. So this is just a snippet. This is not as good as I would expect from you guys. Okay, more information about safety and disposal information. Again, just to give you an example, an idea of what minimum information to write down. Then there's the pre-lab questions, and you always find a pre-lab question if you look deep enough in the experiment. Okay, and the pre-lab is to kind of like make sure that your mind is prepared for the type of calculations that are involved in this experiment, or the type of systems or chemicals that you are going to be working with in this experiment. So these are the pre-lab questions. You would put that after the safety information. Okay, so you basically just answering what the questions are for each experiment as written out in the lab manual. Here's an example of that. This person did some calculation. The pre-lab question, I guess, was about calculation, and this is what they did. They gave keep the water both steady so that the water bath doesn't get upset. So there must have been a question as to why things needs to be stabilized. There's this question right here where they have to actually do a calculation using some data, or show the mathematical relationship between the natural log of the equilibrium constant to its thermodynamic parameters. So these are just answers to the pre-lab questions. Here's more answers to the pre-lab questions. And then your data and observations. So as you're doing the experiment, you're actually writing down everything that's happening. and any data that you're collecting, you should write down in your notebook. And generally, this is where the data table comes in. If you've read the experiment, then you know what data you're collecting. And so if you've already made that data table in your lab notebook or somewhere, then all you got to do is start filling it in and then writing on the side the observations that you are seeing as that data is being collected. Okay, so this right here just tells you about making sure that you write what you are seeing and the data that you're collecting. In the past, what would happen is students would not write the data directly into their notebook. They would write it in a scratch piece of paper, and then thinking that they would write the data later on. That's bad practice. You write the data directly in your lab notebook as you are um, um, generating it. Okay, so you would be given a 5-point penalty if there was any scratch piece of paper around, because you're not practicing good lab practice. So that's why you see this here. But because you guys are observing it in a videotape, as you watch the videotape, write it down and then write down the data, because that's the data that you would be using for your calculation. So this is an example. I think this is experiment number 1, in which they are running a timer and they're collecting the absorbance based on the decay of the solution, the color decay of the solution. And they also have the temperature that was recorded. So this would be a data table for experiment number 1. What you guys are going to be doing is the data table will be generated for you. Okay, and you just need to make sure that you label it correctly. And then, of course, the observation is very important, because you need to write down, like, when does the solution turns completely colorless? What is the intensity of the solution at the beginning versus at the end? What temperature, or if there's any temperature fluctuations throughout the experiment? Those are things that you need to document when you're carrying out the experiment. And so that's what this person did. They wrote their observations. Okay. And then once the data and the observations complete, turn that in, and then go home or take a day or X number of days and think about the results of that experiment based on the objective that's supposed to be carried out of that experiment. So this is the post-lab write-up. The post-lab write-up starts with the processing the data, the calculations, and then the results. So in here, you have processing the data. And that's where you just take the data and you make sense of it and you put it in a form so that you can get meaningful information. You're carrying out a calculation. So processing the data means that you're carrying out a calculation so that you do get the results that you're looking for. And this sort of describes what's involved. A lot of times you guys are going to be generating lots of information and you have to correlate it in a graph. That's especially true for experiment number 1 and experiment number 3. Okay, you guys are going to be collecting a bunch of data and you're going to need to put it in the graph, and then you need to find a correlation somewhere in there. You guys are going to learn about a program called Linus. It's a linear regression, and I'll show you how that's done in activity number 3. You want to make sure you know how to use Linus, because that'll tell you the correlation factor. It'll tell you the intercept. It'll tell you the slope. And usually the intercept and the slope in an experiment have some meaningful information that is involved. So we're going to use a program in Excel called Linus. And if you don't know how to use that, then don't worry, because we have a whole activity number 3, in which you guys are going to be expert in how to use Linus. When you finally get all the results, what you guys are going to be doing is you're going to put it in a table form. So that's what I talked to you guys about right here. Okay. So here's an example of some calculation. I think this is a thermodynamic experiment. And they actually, what you need to do in your calculation is you might be you might be doing like 4 or 5 or even up to 8 or 9 trials. All I need is one trial and go through a sample calculation. So I know exactly that. So I know that you know how to do the math. Okay. Excel is very easy because it automates the calculation for you, but I need to see in a sample calculation how you take the data and get meaningful results. And so this is an example of a sample calculation where they took one piece of data and they actually got a result at the end. So you need to do that in certain experiments. Some experiments do not involve a lot of calculations. It's just a bunch of conclusion, like I think experiment number 3 or experiment number 2, the equilibrium lab. You just have to draw a conclusion based on what's observed. But this is the example of calculations and result. This is a table where you compile the final results in a form that is easily understood. So this is a table that is generated from the calculations. Okay, and then there's a discussion. The discussion should address what is the meaning of your results. It should address what is the significance of your results. Take a look at your objective in the pre-lab. Your objective is the thesis of this experiment, what your aims are. The data and observations are the evidence that you have to reach the objective of this experiment. And then your discussion is to write down in so many words that your data, the results from your data, confirms your objective of this experiment. So you got to write that in there. Okay, the discussion makes sense of the final value that you have. The conclusion is just, it's nothing new. The conclusion simply states what was done and the results that was achieved. It should not contain new information. It's sort of like a summary. In experiment number 1, we studied the kinetics of crystal violet. We found out that the rate law involves second order crystal violet. And that basically is the objective, and that the rate constant at 25 degrees is such and such. It's not providing anything new. It's sort of like summarizing what your experiment found or what your discussion is elaborating on. But it shouldn't add anything new. It just sort of summarizes what happened. It's kind of like if you've seen any scientific journals, there's usually an abstract. And the abstract tells you what that experiment's about and the results that they found. It's kind of like what is found in this conclusion section. Here's an example of a discussion and a conclusion for an experiment that we did a while back where we generated a nickel compound. And this person talks about the different salts that was synthesized and how to distinguish one salt from the other. So it's pretty involved. Okay, they talk about the synthesis part, they talk about the analysis part, and their conclusion based on that. Okay, here's the conclusion. And then, of course, the post-lab write-up. The post-lab write-up, in the lab manual, you'll find questions at the end to kind of like let you think about the experiment. What happens if this happened? What happens if you lost some solution at this step? What would your result be? Okay, what happens if the color, instead of turning purple, it turned red? What is that significant? Okay, so that's the post-lab questions, and you write it after the conclusion. Okay, in the end, that's your lab write-up, but you got to think about the whole experiment, you gotta make sure that it's legible. Okay, since you're typing it up, then it should be legible, but it has to make sense. It's got to be coherent. So in this particular case, these are what I'm looking for in terms of giving you an um, overall presentation of lab book. It's usually about maybe 5% of your overall grade. Lab technique during class was the safety information that you provided in your write-up sufficient? Okay. Did you have headings? Did you follow the format that I recommended? Did you have a pictorial flow chart? Did you show the data table that was to be generated? All that would be part of the overall impression. Is it legible? Is it easy to read? Is it easy to follow? Did you give a sample calculation? Did you give a summary of results? These are all part of the overall impression. Okay, so that basically is your lab notebook. Now, let me just give you some examples of what people did in the past so that you can see exactly what's involved. So I'm going to change gears here, and then I'm going to show you last semester's example of what they did in lab archives. So this person wrote an objective. This is basically the purpose of this experiment. They show the reactions that are going to be taking place, and then they tell me what techniques that they're doing. It's basically observation. They give me the background information. Okay. They talk about each experiment or each reaction that's going to be studied. There are 4 reactions that are going to be studied here. And then they give me a pictorial flow chart. This is a pictorial flow chart of what the steps are for this experiment. They don't give me in the words or an outline. They give me a pictorial flow chart. These are the steps in which this is to take place. Okay. They give me a sample data table. So that's all part of the background information. And then they give me the safety and hazard information. These are the SDS safety data sheet, and they basically took a screenshot of it and then embed it within the report. That way I don't have to open up the document. Okay, and then they also wrote in not so many words extra information that pertains to safety. Then they answered the pre-lab questions. So that right there, this was for a report. For the second report, this was really excellent. Okay, let me give you another example. And that other example will be, let me see. The other example will be the data and observations, and this is the equilibrium. So this is how this particular person took the videos and gave the procedure, gave an observation, and provided an explanation of what was going on. So they put it in a table form. That way it's easy to follow. And these are the different steps involved in the reaction or involved in the experiment. This is what's taking place. This is the observation based on the video that is observed. And this is the explanation of why the color is changing. So you can see it right here that it's pretty organized. It's not just random information. They have it pretty organized based on the procedure that's taking place. I'll give you another example. So this was the equilibrium lab. Let me do the nickel salt experiment. And let me blow this up. Again, this is data and observation. All they're doing is writing the observation based on what they see in the video, and they're taking a screenshot of the procedure. This is basically this is the synthesis part. Okay, this is synthesis description. They're showing what chemicals are being mixed. They're showing what starting materials they have, what is to be done during the experiment, and then the product that is synthesized. That's salt A. This is salt B. Notice salt B is a different color from salt A. And then this is salt C. Okay, and then they have a summary of what the different results are. And then this is the analysis part. The one analysis is a titration experiment. This is the titration curve. Another analysis is a spectroscopy experiment, and this is the absorbance of that result. So that's your data and observation. Okay, and then let me show you how this person did a post-lab experiment. This is the post-lab experiment. Let me blow this up. First thing that they did was they took the data and they did their calculations. And these are the calculations. This is the data, first of all. And then they showed sample calculations of how to get the KSP and the natural log of the KSP for the different trials. There were 6 trials involved in this reaction. Okay. And then they took the results from these 6 trials and they put it in a graph. And from the graph, they were able to get the slope, the intercept, and the correlation factor. And then they were able to put the summary of results in a table. And then after that, they talk about the experiment, give a conclusion. This conclusion is actually longer than I wanted, but that's fine. And then the post-lab questions. And then if there was any table that they wanted to submit, okay, I didn't need tables on this, but this is it right here. They could have submitted a table in the appendix. And this is the data table that they generated during this experiment. It's not part of the report, but if I needed to find information, if I needed detailed information about this right here, okay, if I need the detailed information from how table 1 was generated, then that's what this supplement table was about. It's the raw data that was determined from this particular experiment. So those are just examples of the 3 sections of a lab report: the introduction, the pre-lab, the data and observation, and then the post-lab write-up. Remember that the pre-lab is due before the experiment is carried out, usually when you walk in the door. The data and observation is due when the experiment has been completed, and generally the same day when the experiment is completed, because you're not writing anything new, you're just writing what you observe and the data that is collected during the experiment. So that's generally due when the experiment is done. And then the post-lab is generally due a week and a half later, after you've had time to think about the experiment, what the experiment's about, and then do calculations, and then look at the results and see what meaning that results have. So that's what I wanted to talk to you guys today.